we must first import numpy as np and matplotlib to obtain the results below. So we defined x as well. After finishing all of this, we produced several examples. As you can see, the three photos below are part of the dataset and somewhat blurry, which is the photos is not cleared with blurry. The photos below are all relatively simple to identify. However, some grow pretty complex, affecting the model's output. And the step three is find some supporting functions and recognize the data. Because there are 10 labels, we first specify one hot encoded into the model so that it may more easily redefine the labels. So the step 4 is organize the image data and transpose and reshape some of the images we have collected. They were 32 by 32 by 3 and had to be transposed to 0 by 2 by 3 by 1 to fit in the first convo layer. So these are the four steps which is involved. And moving to the next step, there are some image data simply requesting specific commands to assist in preparing the model for use in the project. Yes, and moving to the next step, initialize weights in filter. This stage will lead us to define several supporting functions that will assist us in building, training, and testing the CNN. Will begin by initializing the filters weight and our bias. And the step 7 is configure the convolutional layer and compute the dot product. And the step 8 is configure the ReLU layer, compute the dot product by x dot w plus b, and set the filter shape to 3. In step 9, create our pooling layer and excuse me, in step 9 creating our pooling layer and reduce our spatial size so that our k size is 1221 and our strides size is 1221. In step 10, create a fully connected layer and conduct the computation input weight plus bias. In step 11, begin constructing our convolutional neural network models. In So the first step is import the TensorFlow as TF because this is the program we will be using to build our model. And the second step is to create a placeholders for input and labels so that this is x and y true, y is true, x is our input and has same shape as the image, y true is our output and it has the shape of 10 because the outputs are in this case 10 labels for our images. And in this step 12, the first convolutional layer is created with a filter 5555332 515 because this is the shape of our camel, and 3 that is because it is our input shape which is 3 color channels, 32 because this is our output. So next we will create our first pooling layer and reduce the spatial size. Then we will create our second convolutional layer and perform computations the same thing as first convolutional layer, except we will change our filter shape 553264. We will use max pooling here. So in this, the following step is developing our second pooling layer and lowering the spatial size generated by the max pool. After we have built off all of our layers, we must reshape and flatten our last layer so that it can fit inside and be a one-dimensional vector so that it can be fit into the initial FC layer. This will take in the form of -1 comma 8 comma 8 comma 64. Next, our loss function we will be defined and the softmax entropy loss will be calculated. Next, we build an optimizer to improve our CNN model and set the learning rate to 0.001. Then we will make a trainer our CNN model. So in this part 3 there is a phase 1 and phase 2. So now we are explaining about everything about the phase 2 which are involved in this. In this phase 2 we are now in, we will train and test our CNN model. To begin we will develop a variable. To begin we will develop a variable initializer of that will be used to initialize all of our variables. After that, we will set our steps to 5000 because we want it to run the data 5000 in the model to train and test it to obtain the best or most accurate results. Next, we will run if a session to train and test the model, and we will also set the chart batch to 100 in this code. This suggests that we want to see 100 step accuracy. This is useful for determining whether there is a significant back gap in the data accuracy. This suggests that we want to see 100 step accuracy. This is useful for determining whether there is a significant gap in the data accuracy. Step 100 equal to 41%. In step 100, the percentage increases significantly to 41% because it is still not very strong, implying that the model can only predict 41% of the time. For example, if you provide an image of a horse, the model will predict that it is a truck, which is not ideal. 2600 steps equal 65% of the model begins to smooth out tiny, but it is still inconsistent. So we may conclude that it's somewhat strong model, but not remarkably so. Everything, the images which are involved and the